Intro to Metabolism. Metabolism is the totality of an organism's chemical reactions. The chemistry of life is organized into metabolic pathways. Metabolic pathways begin with a specific molecule which is then altered in a series of defined steps to form a specific product. Know the difference between catabolic pathways and anabolic pathways. Catabolic pathways release energy by breaking down molecules. Anabolic pathways consume energy to build complex molecules. Energy is fundamental to all metabolic processes, and therefore energy is key to understanding how the living cell works. Organisms transform energy. So what is energy? Energy is the ability to do work. Kinetic energy is energy in motion. Potential energy is stored energy. Chemical energy is a form of potential energy stored in molecules due to the arrangement of their atoms. Energy can be converted from one form to another. The energy transformations of life are subject to two laws of thermodynamics. The first law states that energy can be transferred and transformed. It cannot be created or destroyed. The second law states that every energy transfer or transformation increases the entropy of the universe. How can we determine which reactions occur spontaneously and which ones require an input of energy? We use Gibbs-free energy to measure the spontaneity of a system. The Gibbs-free energy in a system is related to total enthalpy and entropy by the equations in the picture, where T is temperature in Kelvin. The greater the decrease in free energy, the more work a spontaneous process can be performed. Chemical reactions can be classified as either exergonic or endogonic based on free energy. An exergonic reaction is net release of energy, and free energy is negative. A cell does three main kinds of work. Mechanical work, such as beating of cilia, contraction of muscle cells, and movements of chromosomes during cellular respiration. Transport work, the pumping of substances across membranes against the direction of spontaneous movement. Chemical work, driving endogonic reactions such as synthesis of polymers from monomers. Cells manage their energy resources to do this work by energy coupling, the use of exergonic process to drive an endogonic one. In most cases, the immediate source of energy to power cellular work is ATP. When ATP is hydrolyzed in the test tube, the release of free energy merely heats the surrounding water. Enzymes speeds up metabolic reactions by lowering activation energy. Factors that influence enzyme activities are temperature, pH, enzyme concentration, substrate concentration, and inhibitors. For example, there is an optimum level of temperature and pH an enzyme has. When outside of optimum level, they become denatured. What causes denaturation? Extreme temperature and wrong levels of pH can cause denaturation. Enzymes work consistently until they are dissolved or become denatured. So when enzymes become denatured, they are no longer active and cannot function. Enzymes are substrate specific. Their metabolic control also depends on allosteric regulation. Thank you very much. Please visit our weekly website for more info on metabolism.